Today we're going to review some more of the reteaching, and we're starting on page 290. So in set D, in 290. So we're going to be looking for partial quotients, and you remember they're illustrated off to the left, explaining how to do it, going through the steps. So I'll be going through step by step as well. So you want your notebook handy so you can rewrite the problem. 30 goes into 570. If we do 30 times 10, that's 300. And if we do, 30, let's see how many times does 3 go into 27. That's 9. 30 times 9 is 270. So my final answer is 19. Number 2, 17 goes into 714. I could do 17 times 10 times 10 times 10. I could keep doing that all over again, but let me get some more room here. $17 goes into 714. Multiples of 17. If I double 17, well, we'll do the tens. I'll take it slow. 17 times 10 is 170. And be careful on your subtraction here. You take it out again. Those of you that know how to use standard long division, of course, you can go in and just do standard long division. You do not have to do partial products. So I'm going to have 10, 20, 30, 40 plus 2 is 42. And we had 19 for number 1, remember? Number 3, 24 into 984. 24 times 10, 240. And if I know 24 times 20, if I know 24 times 2 is 48, I could always, be bold and go beyond the 10. So when I add all that, 10, 20, 10, and 1, it is going to get me 41. So my final answer would be 41 on that one. Number 4, 40 goes into 920. And I know 40 times 10 will be 400, but I know 40 times 20 will be 800. That'll get me out a little bit quicker. And using my front-end estimation skills, 4 goes into 12 3 times, so 40 times 3 is 120. So I've got, when I combine that, I get 23 for my final answer for number 4. For number 5, 13 times 10 is 130. I think I'll be doing that a lot here, so maybe I'll do 13 times 20. So 13 times 2. Notice we're doing a lot of subtraction here. We've got to make sure our subtraction is accurate. And 13 goes into 78. I know 13 times 2 is 26, so keep subtracting that out. And another 26. Oops. Let me get back up here. Hold on a little bit. Let me see. Let me go right here. I got everything so jammed in here, I can't even keep track of my own work. Okay. All right. So 598 minus 260 is 83. There we go. There's my problem. Messy Mrs. Brennan. All right. So there we go. Now that's better. I thought something didn't look right there. Okay. So now I'm going to do, I'm going to check it off to the side. 13 times 4 is 52, but I want an 8 in my ones place. How am I going to get an 8 in my ones place? 13, oops. 13 times 3, 9. 13 times 4 is 12. 13 times 5, 15. 13 times 6. That will get me that 8 in that ones place. There we go. So my final answer, 20, 40, 66. So for number 5, we have 66. And again, you're only doing odds or evens on here. So whatever the assignment is. I'm doing the whole page because other teachers are using this, so you can always skip and go to the number that you're working on. 986 divided by 29. If I do 29 times 10, 290. Another 10, 290. Another 10, 290. And I can't take another 10 out again, so about 29 times 2 is 9 times 2 is 18. That's 58. Let's see. Something's not looking right here again, too. All right, 980 minus 290. Make sure I carried in 5, 1, 2. Okay. 10, 20, 30. I'm starting this one over. All right. 29, 986. You know what? I'm going to do this one using the traditional algorithm. 29 goes into 98. I can round that up to 30. How many times does 30 go? How many times can I take 30 out of 98? 3 times. So off to the side, 29 times 3. 6, 7, 8. So I divide, I multiply, I subtract, I compare, and I bring down. 29 goes into 116. It's going to be more than 3 times. I'm going to think it's maybe around 4. Well, how about if I do it again? How about if I take 3 out again? And I'll show you how you're combining partial products with the traditional algorithm. And then I'm just going to put that little 1 up there. So my answer is going to be 34. So that was using the algorithm and using partial products. So you're correcting as you go with the partial product model. Even the people that are confident in doing the algorithm, when you get down to that compare, when you're comparing your remainder to your divisor and you're seeing you didn't take enough out, you can always correct as you go. You don't have to redo the whole problem. Let me do another one with traditional division. 13 going into 85. Let's see. If I round that up to 15, how many times? So what I'm doing here is I am taking 858 divided by 13, and I'm thinking maybe 15 and 750. So I know that's 5, so let me try that. 13 times 5, 65. That's more than that. 13 times 6, 78. Let's see. And 13 times 7. I'm going to leave this over here because I might need it later on. 91. So I'm going to go with 13 times 6, 78. Divide, multiply, subtract, compare, and bring down. So my answer is 66 for that one. And let's see, which one am I on now? Number 6, 29. So if you're in my class, I don't expect you to do all these. Remember, you're doing odds or evens, whatever's assigned to Google Classroom. 29 goes into 98. We'll say 3 times. And also you can be using some compensation on this. So if I'm trying to multiply 29 times 3 in my head, I actually could do that. What I do in my head is 30 times 3, solve a simpler problem and bring over that 0. And I'm going to subtract out 1 times 3. So I'm going to subtract out 3, so I get an 87. You kids that are good with mental math, you can try to do that in your head so you don't have to be chicken scratching off to the side. But if you have to, then that's fine. Of course, you can do that. So if you have to just multiply, don't erase when you're multiplying because you might need it later on in the same problem. So if I find my target and I think, well, 30 goes into 98 about 3 times, so I'm going to try that. Then you can do that off to the side. Coming back to my problem, I am subtracting, and I get 11, bring down the 6, and 29 goes into 116. If I said, I feel like I just did this one 3 times, add the 1, combine them, and you get 34. And number 7, 35 goes into 980. 35 times 2 is 70. Now, how many 70s can I get out of 48? If I'm thinking mental math wise, how many pairs of 35 can I get out of there? It's 4. So that helps me target. If you can't figure that out in your head, you just think to yourself, 35 times 10 is 350. Half of that is less than 280. So I know my answer is going to be between 5 and 10. So 8 is a good number if you're just trying to figure out where you want to begin with this. But I'm using a lot of mental math strategies to make some logical choices for where I'm going to start on my problem. So, and last one here, number 8, 73 goes into 803. And you know 73, this is a good one for using our partial quotients because we can get that real fast. 11. And partial quotients can sometimes get you the answer quicker than using the algorithm. So that was set D, and I know that's a lot. That's why I only have you doing half of them. All right, so now I'm going to, on this section, on set E, you can check your answer by multiplying the quotient by the divisor, then adding the remainder. So we're going to go and just plug away on these. I think these were kind of easier than the one before. So if I use partial quotients, I know that's 21. Number 2, 30 goes into 540. Again, I could use partial quotients. So that's 18. I'll do some of the problems with just the algorithm. Number 3. Where's my answer going to start? Well, 40 can't go into 3 and it can't go into 38, so it's going to start in the ones place. So how many times does 40 go into 387? So I know it's going to be smaller than 10, obviously. So why don't I try 9? And solving a simpler problem, 4 times 9 is 36. And remember, don't forget that 0 on there. And so I would have a remainder of 27. 9, remainder 27. Number 4, 50 goes into 653. If you use partial quotients, you can peck away at the problem. So I have 13, remainder 3. Okay, number 5, 60 goes into 840. If I want to use traditional algorithm, 60 goes into 84 once. Subtract it out. Compare. 24 is smaller than 60, so I'm going to bring down the 0. 6 goes into 24 4 times. So 60 times 40 is 240. So my answer is 14. 70 goes into 910. I know that 7 does not go into 91 evenly, so I'm pretty sure I'm going to have a remainder on this one, but maybe not. We'll see what happens. Maybe not, because we have zeros in both, so we'll see. All right, so how many times, if you want to use front-end estimation, how many times can you take 7 out of 9? You could start with that. So you can do 100. Oh, look, it does go in evenly. And how many times can 7 go into 21? 3 times, 70 times. Oops, what was I doing there? Back up, gang. 7 times 10. 70 times 10. There we go. 70 times 10 is 700. 70 times 3 is 210. So we could combine that. Our answer is 13. I think I need a coffee break. And let's see. Number 7, 80 goes into 698. We know we're going to wind up with a 1-digit answer on this one and definitely a remainder. So how many times can we get 8? 80 times 8 times 8 is 64. And so that one's simply 8 with a remainder of 58. And number 8, 90 into 8, 4, 9. Again, I'm going to have a single digit answer here because 90 can't go into 84. So using my 9 times tables, I'm going to get as close as I can to 84, but stay under 84. So 9 times 9 is 81. So that one's 9 with a remainder of 39. And Ivan uses 30 craft sticks to make each toy cabin. He has a box of 342 craft sticks. How many cabins can he make? So we can use the partial quotients method, or you can use it, if you know how to use the traditional algorithm, you can be using the traditional algorithm. So we have 11 he can make with 12 as a remainder. So he can make 11 cabins and then he'll have 12 sticks left over. All right, let's move down. Oh no, we're on the next page. Now, I know you have to persevere. This takes forever, but without completing division problem, tell which place to write the first division, which place to write each quotient. So in this one, you actually don't have to solve them. You only have to tell me what place you would start the answer in. This is kind of silly. It looks like this lesson should be before the other lesson. But so when we're starting, we're going to say 14 doesn't go into 9, but it can go into 96. So we're going to start that. The answer will start in the tens place. 53 can't go into 6, but it can go into 65. So this answer, the first digit in our quotient, will be in the hundreds place. 91 can't go into 7. It can't go into 72. So we're only going to have a one-digit answer. So this one starts in the ones place. So one digit. 72 can't go into 2. It can't go into 23, but it can go into 237. So our answer will start in the tens place. 26 can't go into 8, but it can go into 81. So hundreds. 68 can't go into 6. It can't go into 61, but it can go into 612. So that one's in the ones. 40 can't go into 5, but it can go into 55. So we got the hundreds on that one. And 39 can't go into 3, can't go into 38. It's going to have to go into 386. So this one will be in the tens. And as we move down, remember you can check your answer by multiplying the quotient by the divisor and then adding the remainder. So we can always check our work. So let's see, this is our last page of computation here. 16 goes into 2, 2, 4. I'm going to use the traditional algorithm. So 16 doesn't go into 2. It goes into 22 one time. I divided. I'm going to subtract. I'm going to compare my 6 to my 16 and bring down. 16 times 4 is 64. If you didn't know that, you'd have to do some multiplication off to the side until you get that. 38 goes in, and use your times table chart too. That can really help you on this because it gives you a good starting point for some of these problems. So 38 doesn't go into 7. It goes into 79 2 times. 38 times 2. We subtract, compare, and bring down. 38 doesn't go into 32, so be careful on this one. I'm going to have to annex a 0 there. Because remember, our answer started in the tens place. So this one is 20, remainder 32. Don't forget to make sure your answers are all lined up nice so you can make sure your place value, your numbers are in the right, digits are in the right place value. Number 3, 42 into 504 goes one time. So we have a very badly written 8. Bring down the 4. 42 goes into 84 twice. 42 times 2 is 84. So we have no remainder on that one, just 12. And for number 4, 47 going into 5170. 47 will go into 51 one time. Notice I've got everything nicely lined up, so I make sure my place values are all lined up. 51 minus 47 is 4. I bring down my 7. 47 into 47 is 1. I got another 0 to bring down. Don't make your answer 11. It's 110. Don't forget to annex that 0. It's a placeholder, and it changes the value of your answer. So make sure you have that in there. 58, 7, 2, 1, 1. So 58 times 2 would be too much. So 58 times 1. Subtract that out. The remainder of 14, that looks good. Bring down the 1. 58 times 2. And in my head, what I'm doing, if I'm trying to figure out 58 times 2, I'm doing 60 times 2 is 120. And I'm subtracting out 2 times 2, which is 4. So I'm getting 116. In case you're wondering how I'm doing that. In my head. You can also do off to the side 58 times 2. You can do that as well. But I'm doing this in my head. You want to try to get to that point where you can do some of this computation in your head. It'll make things go quicker for you, believe it or not. And I've got one more number to bring down. So 58 into 251. Again, I'm thinking 60. And 60 times 4 is 240. So I'm going to do 58 times 4. And subtract that out. So I have 124, remainder 19. So you would write that answer, 124, and we put in R, 19. So we know we're talking about a remainder here. Number 6, 12 going into 3, 5, 4, 9. If you do your 12 times tables, you know 12 times 2 is 24. 12 times 3 is 36. That would be too much. So 24. 12 times 10 is 120. That's going to be too much if you know your 12 times tables. If you know them, what am I on? I'm on number... Okay. 12 times 9. Oh, wait, let me think now. 12 times 9. Remember, do it off to the side. It's 108. You can also, on that, you can also do benchmarks like 12 times 10. I'm going to do this one using partial products too when I'm done, just to give you the other way to do it and how sometimes partial products is actually easier. 12 times 5 is 60. I just know that math fact. So I have 295, remainder 9. I'm going to do that one again using partial quotients. Quotients. I keep saying partial products. You know what I mean. So if I did 12 times 200, I would get 2400. And if I do 12 times, I can't do 12 times 10, so I would do 12 times 90. Remember we said 12, remember we did 12 times 9. Oops. Is 108. So 12 times 90 would be 1080. So I'd have 290, and I've got 12 times 5 equals 60. So I've got 295, remainder 9. So that's using the partial quotients method. Well, either way, as long as you get your answer. Number 7, 25 into 1352. 25 doesn't go into 1. It doesn't go into 13. So I'm going to be looking at 25. How many 25s can I get out of 135? And think of quarters. You probably could do this in your head, and you would know that it would our first digit is going to be placed in the tens place, and it's going to be a 5. 25 times 5 is 125. Our remainder is 10, which is smaller than 25, so we're going to bring down our next digit. And 25 goes into 102, and think of quarters. 25 is like a quarter. How many quarters can you get out of $1, which is like 100 cents? So 25 times 4. Well, that one would be 54, remainder 2. Number 8, 33 goes into 1500. Our problem is not going to start in the thousands. It's not going to start in the hundreds. It's going to start in the tens place. So 33 goes into 150. I think about 4 times. Check that out, because 5 would be too big. Yep, that looks good. And if you make mistakes along the way, you can always correct them as if you were using your partial quotients. So we said it's 4, and I think times 5. 33 times 5. 165. So it's 45, remainder 15. Over here on the side, when I was trying to figure things out, I have 33 times 4. I can actually just add another 33 to that because I kept the math over there. And remember, 4 plus 1 is 5. So 33 times 5 is 165. So that one's 45, remainder 15. And the next one, 9. We're almost done, gang. 42 goes into 5825 one time. We're starting in the hundreds place because 45 obviously can't go into 5, but it can go into 52. So bring down the 2. How many times does 42 go into 116? Well, I know 40 will go into 164 times, but it's actually 42. So I'm going to say 3 times. Oops. So we'll do 42 times 3. It's 126. 36 looks good. It's smaller than 42, so I'm going to bring down my next digit, 365. How many times does 42 go into 365? So I'm thinking in my head, how many times does 40 go into 360? So that would be 8 times. So let me try that. I think that's the best place to start. So if I put an 8 here, so I have 138, remainder 29. I'm going to do that problem again using partial products. So let me do this using partial products. I just want to make sure you understand how to do both. So if I said 48 times 100 would be 4200. And then if I do 42 times, let's say 20, 42 times 2 is 84. So I'll subtract out 840. And 42 times 10, 420. So yeah, do it again. Nope, no, I can't do it again. That's too big. So I have 42 goes into 360 how many times? So again, 40, that's kind of like the other problem. 40 times 8. So 42 times 8. And I erased that over here. Shouldn't have done that. So 3, 3, 6. So a 9, 29 is my remainder. So I combine all this. I get 100 plus 20 plus 10 plus 8 is 138, remainder 29. Same answer, just different method to get there. And the last one, 28 into 2941. Problem's not going to start in the thousands. It's going to start in the hundreds. Bring down the 4. Be careful on this one. 28 doesn't go into 14, so I'm going to need to bring down the next digit. So 28 goes into 141. 30 will go in to 114. I think it's about 5 times. Let me double check. Oh, perfect. So it's 105, remainder 1. And just for fun, let's do that one using partial quotients. So I'm going to do it 100. And then I remember that was 5. So sometimes your partial quotients will get you there quicker. So it's 105, remainder 1. All right. So we're going to stop there.